We will see in this tutorial, how to create a board, with the Shaper Wave Dynamics software. In the Shape Room tab, we can modify and create boards. There are several ways to create boards. The first way, the simplest, is to select a model, and use it as a support to make our board. Here, in the File menu, you have Load Basic Board, which allows us to select a type of board, among 5 default models. We could also use the library, and select a board from our local library. So it is interesting to note here that, in the library, we see that there are boards, which have a small pie chart, like these, and others which do not have. This small pie chart indicates that the board contains its hydrodynamic performance, which has been recorded. It's a hydroscan. These hydrodynamic performances allow us to test the board, in a wave, in the wave room. When we select a board, we will see that there are some that have their scan that has been saved, and others that have no scan. Here we select a default short board, drag it into the interface, and it loads the board that was selected. We see at the bottom of the interface the loading status of the board. You can notice that the software is loading angles. This means that it is loading the hydrodynamic scan of the board at the same time that it is loading the board. When I go back to my project here, top left, project, I see that the symbol of the board has the small pie chart, which means that it has its hydrodynamic scan. We cannot modify the board if it has its hydrodynamic scan, because the performance of the board is linked to its shape. So to start, when using a board as a model, you have to create a copy of it without hydrodynamic scanning. And we can thus modify the shape of the board as we want. So here we have created, and loaded, a copy of the board. And we see in the tree here, that its symbol no longer has small pie charts. So in the outline, here, in the Shape tab at the bottom, we can modify its shape. That's the first point. So 1. Unlock a board when just loaded. Now that we have unlocked our board, we will see how to modify its shape. So, what is the shape of a board? In Shaper Wave Dynamics, we use the basic principles of the shaper. The shaper defines a board following certain well-known parameters. When describing a board, we are talking about its outline, which is a very important parameter. We are also going to talk about its rear, the custom tail. It can be swallow, square, rounded. When defining a board, we are also going to talk about its rocker, and the way in which the bottom of the board evolves. Here we will see the rocker of this board. That we could modify. And we are also going to talk about the sections that make up the board. Sections are plank slices. To select the sections, we use the slider at the bottom right, and we have access to the different sections, which make up the board. We can thus modify the volume of the board. We will see how to show the board under different aspects before going further. So here in the bottom tabs we have board aspect. We can show the board in different aspects to work on it. We see in the shaping phase that the board is shown finished, with the decoration that has been plated on it. For the modification of the shape, it is not interesting to show this phase. We are going to start the shape phase, which shows us the different bevels that make up the board, and the thicknesses at different places on the board. It is an interesting mode of observation of the board. At this stage, we are going to hide the fins. We see in the Aspect tab that we can show the board in wireframe, in volume, or in points, and make the sections appear permanently, to have a vision of the evolution of the volumes and the rails of the board. So there you have it, different ways to show the board. Here, we can show the bevels, and we see a kind of skeleton of the board like that. So, to modify this board, we will act on its outline, on its sections, and on its rocker. We could go directly to work on the sections, on the outline, and the rocker, and modify them point by point, to enter into a very precise definition of the board. But at the software discovery stage, we will use elements in the library, which we will drag and drop into our project. To choose an outline in the library, we will select it among the different outlines, and we drag it on our 3D interface. To modify the outline of our board, the easiest way to apply an outline is to use an existing template. So, to create the outline, we can go to the library, select an outline, and drag it into our project. We see that the insertion of our outline has not modified the back of the board, which remains here a custom tail, in Swallow. We could remove this custom tail simply by deleting it here. We will then only have the custom outline. We also have a function, which allows us to modify the outline, quite intuitively and quickly. We are going to remove the custom outline. And here we are, in determining the outline, the simplest, which exists in the software. We will be able to play with sliders, to modify the camber position, the width of the tail. And we can create our outline like this, just by modifying these sliders. In order to obtain the shape that interests us, at this stage, we have already entered into a definition of the detailed outline. The easiest way to create the outline is to use templates. Here, we will look for a model. When loading a model, we can see that in the outline, we have actually loaded a custom outline. If I remove the custom outline here, we get a very simple slider definition. But, even if the cursors allow us to do many things, and to choose varied shapes, almost infinitely, and allow us to quickly draw outlines, this way of managing the outline by cursors can be limiting. When, for example, you want to make a copy of a well-determined shape. This is why we have another way of drawing the outline, which consists of making a custom outline. So I click on Add Custom Outline, to load the creation interface of custom outlines. Here we see the interface for creating custom outlines, where we will be able to draw a shape point by point. This outline interface will be the subject of a separate tutorial. Here, we will stay on a basic presentation of board creation. So here we are going to load a custom outline, classic. Like this one. So we see that when we imported an outline from the library, we actually imported a custom outline. We are now going to look at the sections, and see how to modify our board, at the level of its sections. So we can select the sections, with the cursor here. And we can say that at a given place, we would like to enter a section. So in my tree, here I have sections, which I just choose from the library, and here, I would like to put this section, here, at level 4. I take my section and I just drop it in the project. It will be grafted at the level of section 4. We have the choice to import the thickness of the section or not. We will preserve the current thickness of the board. I preserve. So there, we just changed the section at this level. We see appearing here, the section that has just been imported. We are going to show in the Aspects tab, the sections here, and we are going to put the drawing in points to see them well. Here, we loaded a section. When I have just modified a section, we can use the clean shape function. All of the sections of the board will thus be averaged. In order to obtain a series of sections, which do not have too great variations in shape. So in fact, when we have just loaded a section, the clean shape function smooths our series of sections. This smoothing can be a problem, because in fact, when loading a section, or only modifying a section, if we use the clean shape function, we risk completely erasing the imported section. So if we want to load sections, to redefine a board, we'll select a series of sections, here. And thus import a whole series of sections. Here, for example, we will import the Fish Basic section series. And there, the whole board will receive new sections, which will be more harmonious between them. This import of the series of sections will therefore create a real modification on the whole of the board in terms of thickness. Here we have our board which has been modified in terms of section. I will show it in volume here. In Shaperwave Dynamics, we use modules that we record, and that we can drag from one board to another. This is very practical, to increase our knowledge base. So, whenever we have a board, we can go into the project to see, here, its series of sections. We can make the sections appear here. If I like this section series, and I want to make a model of it, I will select the section series in the project, right-click, and save section series as. To save it, save, and there, I'll go back to my library, and see in my section series here, that I have saved the section series, which will be available to be dragged into another spread. I'll give it a try right away. I load a board. You will see that I have chosen a board without HydroScan, therefore not locked in terms of shape, so I can work on it without having to generate a copy. So here I see my series of sections. I want instead to use the series of sections that I saved earlier. I select it from my library, and I drag it into this board here. So we created a hybrid board of two models. We note here one of the assets of Shaperwave Dynamics, which is to work by modules. It's an original design approach, which we call modular. It is estimated that the board is made of different modules, the custom outline, possibly a tail, a series of sections, a series of rails, a rocker, and possibly an image. So we're going to see these three modules that make up the board. It's the couple of rockers because there are two rockers on a board. The one we call the sole rocker central, and rail rocker, which together define the shape of the bottom. Let's take the time to define the rocker of a board. I take the rocker which is commonly called the board rocker. This is the rocker of the central batten. We see how the center batten comes tangent and a horizontal line here, which is centered on the wide point. If we draw another line of rocker, at the level of the rails, and compare the curves, at the level of the central slat, and at the level of the rail, we see the way the bottom is presented, i.e. it will be concave, or belly, if the bottom, at rail level is above, from the bottom at the level of the central slat, here I will strongly accentuate. And we realize that my board is going to be rounded belly in front. It is at the level of the rockers that we will determine the way in which the bottom is presented, either in concave if I go down below here. I went down with my rails record. If I go down my rails record line below, from the center rocker, I will create a concave. And there, we can see that my board is becoming concave. Same thing for the V behind. Here the board is flat, because my rail rocker and my center rocker are on the same level, but if I had a rail rocker, which goes above the center rocker, I'm going to do a V in the back. I will emphasize here, so that it is clearly visible, apply to the project. And we observe a strong V. This approach by two lines of rocker, a central line which follows the central strut, and a rail line, which defines the angle of the bottom, allows us to carve the board, maintaining these sections. We don't need to redraw the sections, we just modify the rocker lines. This is a significant time saver offered by Shaperwave Dynamics, and above all, it's really the parameters that are influential, in terms of the board's dynamics, which depends on the way in which the water current is diverted. Here we have created the rocker manually, but as with the other modules, such as the outline and the series of sections, we also have the option of inserting a couple of rockers. So in my library, I select a rocker for this board, and I drag it into my project. The board is therefore reformed with this couple of rockers. With Shaperwave Dynamics, we therefore have the possibility of creating a board, simply by using modules, outlines, tails, rockers, rails, and sections to create a board, by playing with bricks, to define our new board. So we keep everything we've done, the rail shapes, the section shapes, and we put them in our library. We pass them from one board to another, maintaining our know-how, and increasing our library. We can thus create more and more quickly, and efficiently, new boards. One more thing, you have to separate the shape of the board, what it is in terms of modules, outlines, rails, sections, from its size. In the Shape tab, we will modify the sections, the outlines, we will thus modify the shape. But if we speak in terms of dimensions, we see here, for example, that we can modify the length of a board, increase it to 2 meters. This does not change the shape of the board. Shapes can be enlarged or reduced, without changing. This is a very important point because, if you don't modify the shape, you don't modify the hydroscan. That is to say that if we have calculated the hydrodynamic performance for a given shape, well, we can change its dimension, without having to recalculate its hydroscan. When we have calculated a hydroscan for a shape, we will be able to use this board in the wave room, or analyze its performance without having to do any calculations, even if we modify the size of the board. There are two things that can be modified without modifying the shape of the bottom. They are the length and the volume. In terms of the hydrodynamics of the plan of the bottom, the volume, above the middle of the rail, does not modify the performances. The volume will modify the hydrostatic component, which will be integrated into the schedule performance, in a separate calculation. But for the hydrodynamic scan, we will keep the planing information related to the shape of the bottom, even if we change the volume of the board, because the volume variation function preserves the shape of the bottom, so the parameters of length and volume are very easily modifiable. We apply and modify the length, we can choose the volume to obtain a board, more or less floating. So we make the board lose weight a little, which goes to 37 liters. That's the end of this first tutorial for getting started with the Shape Room, from the Shaper Wave Dynamics software.